All right, so let's continue with 5.3. Now we're getting away from that that in-center and circumcenter and all that kind of stuff, all right? This is really a lot different. It doesn't even seem like it should be in the same chapter as the stuff that we just finished doing, all right? It's way, way different. Doesn't mean it's harder, doesn't mean it's easier. In fact, I tell you the truth, I think it might be a little bit easier to understand. So I will say that. So let's talk about this thing. I'm going to write this down. It's called, well, got it put, there we go. Now it should work. It's called the comparison property. All right, you don't have to really remember the name of this or anything. It's not that big of a deal to remember the name of it, but what we're showing is what I want you to really remember. So here it is. I'm going to write it out. You're going to look at it and you're going to say, I don't know what that means. I'm going to show you an example and you're going to like, oh yeah, okay, that makes sense. I hope. So it says if A equals B plus C, definitely write that down, and C is greater than 0. We all know that symbol, right? Greater than, less than. So that C is greater than 0. Then, remember if-then statements? We've done a lot of if-then statements in here. Then A is greater than B. Everybody see that? What in the world does that mean? It probably means nothing to you. But let's put some actual numbers in here instead of letters. Then it'll mean something to you, all right? If A equals B plus C. So I used 7 for A. And then what numbers add up to be 7? Give me a couple numbers that add up to be 7. There's several. 3 plus 4.
6 plus 1.
What? 1 plus 6. Okay, I thought you said 4 plus 6. Right, 1 plus 6. 2 plus 5, right? 7 plus 0. But if I said 7 plus 0, could I use that? No, because it says what? C cannot be greater than 0, but it could be what? I'm sorry, it says that C has to be greater than 0. So could C be 0? No, so I'm not going to use that. Let's use 3 and 4, all right? Would you agree that that equals?
Yep.
Yeah, 7 equals 3 plus 4. You can use any numbers. Any two numbers that add up to be 7, but neither one of these are 0, okay? So just regular numbers, they add up to be 7. Everybody got that? What does this say then? It says then A must be what? What's that symbol? Greater than B. So what's my A right here? It's the 7. That's the A. See, if A equals B plus C. So this is my B, and this is the C. All right? So what does this thing say? If these two numbers equal each other, if 7 equals 3 plus 4, what does my comparison property tell me? It says then A, which is what? 7, has got to be greater than what? B, which is what? 3. Or you could also, let's not say or, let's say and, because both of these things are true. All right? And you could also say what? 7 must also be greater than what else? Because I could switch the 3 and the 4 around, right? So you could say 7's got to be greater than 3, and 7 also has to be greater than 4. Well, give me a number. 4, right? Which is the C. You are correct. Does that make sense? Think about it. If you have two numbers, everybody look up here. If you got two numbers right here, and they add up to be this big number, right? The big number has got to be bigger than the other two numbers. Agreed? So if these two things, 3 and 4, you can use any numbers. Okay, if 3 and 4 add up to be 7, that means the 7, the biggest number, has got to be bigger than the two things that added up to be. I don't know, did that make sense or not? Yeah? So if I take two numbers and I add them together, my answer has to be bigger than either one of those two numbers that I added together. I think that's a good explanation. Do you hear what I said? I see people turning around and not concentrating. Listen to what I'm saying. If I have two numbers and I add them together, I get an answer, don't I? Right? The answer has got to be bigger than either of those two numbers that I added together. Right? All right, that's what the comparison property is saying. Yes? Well, this is not really going to be a test question. This is just leading us up to something else, okay? I just want us to understand. I'll show you some problems that we're going to have with the test. This isn't really a test question, but this is just going to lead us up to something else, all right? So these are just numbers. Well, this is geometry. So what do we deal in? We deal with what? shapes. We deal with a lot of shapes, all right? And so let's use this concept right here to deal with some shapes. And you've actually already seen this before. Well, you've seen what I'm going to draw. The concept is a little bit different. So if I do this, remember this? You've seen this before, haven't you? Do you remember the exterior angle? We'll call that angle 1. All right, and I'll call this angle C. I'll call this angle B. And I'll call this A. All right, but this big angle right there is angle 1. What do you remember about this angle, the name of the angle? It's angle 1, but if I was to explain what that angle is, it's the what angle of the triangle. We talked about this quite a bit. It's the outside, but we don't say outside. What do we use in geometry? We say it's the what? The exterior. You got it. This is the exterior angle. All right? I'll just shorten it, exterior angle. That's my exterior angle. Do you remember the formula or the little equation that we came up with the exterior angle? The exterior angle is equal to, remember this? The sum. Is it ringing a bell at all? Of the remote. Very good. That's the word I wanted you to remember. The remote, what? Interior, talk to me, angles. What does that mean? Okay, which one is the exterior angle? Angle 1. Angle 1 is, okay? Angle 1 is the exterior angle. So what does this say? The sum of the remote exterior angles is equal to the sum of the remote interior angles is equal to the exterior angle. So angle 1 equals, what two angles add up to be angle 1? Again, this is not new. Angle C and, no, A is next to this. B is remote. These are the ones that are further away from the angle 1. So angle C plus what? Angle B. Correct? So what does that mean? That means, according to this comparison thing that we just did over there, look, I've got this thing is equal to these two, correct? So that means angle 1 has to be bigger than what else? This angle 1's got to be bigger than what? Angle C. And angle 1 has to be bigger than what else? Angle B. That's right. Do you see that? So we took that comparison property and now we're relating it to geometry. We took it just from numbers and now we're looking at it as geometry. All right? So angle 1 has got to be bigger than C and B. Let's just put some numbers in there just for fun. All right? So it's an obtuse angle. So give me a nice, easy to work with obtuse angle. What do you think that is? Come on, somebody give me a number. 3. Come on. It's an obtuse angle. 50? 50 is an obtuse angle?
180.
102? Okay, let's say 100. All right, let's say this looks. You can't say 60. Listen. Okay, stop playing around. All right, listen. You cannot say 60. You can't say 70. You can't say 50. Why not? It's an obtuse angle. So an obtuse angle. Say it again. 150. Okay, that's an obtuse angle. Anything bigger than what? Than 90 degrees. Okay. I like, would you say 150? 115? So you said, let's pick something really easy. Let's go like 120. Is that all right? Let's say it's 120. And let's say that this was, I don't want to go 60. Let's say this was 70 degrees right there. What's this angle right here going to be? Angle B. 120? Angle B is 120? Come on, look at it. It's an acute angle. There's no way that could be 120. Remember, these two have to add up to be 120. It's not 30. 30 and 70 is 100. 50, right. 50 and 70 is 120. Okay? Now, here's what I'm trying to get at. Let's say you knew this situation. What they want to do is they want to compare. when you compare something, you're saying one thing is either equal to something else, or one thing is either greater than something else, or that thing is what? What's the other? Is less than something. Agreed? You know, I got three choices. If I'm comparing two numbers together, one number is either equal to the other number, right? Or this number is greater than the other one, or it's what? Less than the other one. Are there any other options? No. They actually have a fancy word for that. You want to hear the fancy word? They call it a trichotomy. Tri meaning what? Tri meaning three. And then I don't know where they get this word from. Trichotomy. All right. Trichotomy means you got three choices. That's basically what it means. Okay. Three choices. Either your first number is equal to the second number, your first number is bigger than, or your first number is less than. So let's take a look at this. Let's compare 120 to 70. What if I compared 120? What is 120 to 70? Is it equal? Is it greater than? Is it less than? It's greater than the 70. Okay? Let's compare it to the other angle. So this 120 is what compared to this angle right here? It's greater than 50. That's where the comparison property thing comes in. Okay? So what does this mean? It means the exterior angle is always greater than either one of these remote interior angles. Okay? I just stuck actual numbers in there to just make it a little more sense to us. Okay? But this exterior angle is always going to be bigger than this. So that's what we discussed right here. We call this angle 1 to begin with. Right? So angle 1 is bigger than C. Angle 1 is bigger than B. Got it? That's the only thing that this really said. They gave this a name. I'm not going to write it down. Oh, let's write it down. They call it the exterior angle inequality. Inequality. Where do they get that word? Why inequality?
It's inside.
No. Equality means the two things are what to each other? Equal to each other. Let's use the word. If it's equality, then they are equal. If it's inequality, then they are not equal. Okay, the IN in front of it doesn't mean it's inside the thing. It means it's not. It's not equal. Okay? Give me a word that you put the IN in front of it, it means it's not. How about appropriate? That's the only thing, that's the first word that popped in my head. You got appropriate, and then you have what? Inappropriate, which means it's what? It's not appropriate. Okay? There's probably hundreds of other words we can think of. I'm not going to do that. All right, so let's do another one. What I'm going to do now is I'm going to compare two triangles this time. So let me try to draw it similar. Stop the whistling, please. I'm going to try to draw them similar to the way I have them in my notes. So that one looks like that. And this one looks like this. Are you writing them down? This will keep you out of trouble if you actually start writing. See, the problem is I start writing stuff and you guys decide, well, I'm just going to just goof off until he's finished writing them down. It's not the way it's supposed to work. All right, let's talk about this. I could just write everything down, but I'm going to talk about this in a second. A lot of times in geometry we do this. If we call this angle A, the side that's opposite angle A, this is what we do a lot of times. Not all the time. You don't have to do this, but they do this a lot. If they call this angle A, they call this side what? A. And I make it lowercase because lowercase is talking about the length of the segment. The uppercase is talking about the measure of the angle. So if this is angle B, what would I call this one right here? Lowercase b, and this would be a lower c right there. Okay? I'm going to put some degrees in here. So that's 100 degrees. This one is 60 degrees, and this would be 20 degrees. All right? And let's do something else. Let's just stop right there. We're not going to compare these two triangles. Let's just do it like this. Here's what this says. This is called the greater angle theorem. Again, you don't have to memorize a name or anything like that, but that's what they call it. The greater angle. So let's take a look at it. Let's see which one is the greater angle. Which one is the greater angle? Which one is the biggest angle in this triangle right here? Angle B, right. It's 100 degrees. That's bigger than 60, bigger than 20. Would you agree? Now, here's what the theorem says. This is pretty interesting, and it's very, very useful. We use this a lot from here on out. Okay, in other chapters, okay, we use this quite a bit. So this says if angle B is the biggest angle, then what do you think might be true about side B? Compare side B to the other two sides. That has to be the what? The biggest side. You got it. Okay? The side that's opposite the biggest angle. Listen to me. Everybody listening? The side that's opposite the biggest angle is the biggest side. Therefore, the side opposite the smallest angle, talk to me, is the smallest side. And of course, the one that's opposite the middle one is the one that's in the middle. So here's a question. Amir, you talked about on a test or a quiz. This is the kind of stuff that I could ask on a quiz or a test. Okay, I would say something like, list the lengths of the sides in order from largest to smallest. You hear what I just said? I'm not going to write all that down, but list the sides in order from the largest side to the smallest side. All right, so how do I know which one's the largest side? Now look at A and B. If I was just to look at it, right, I didn't have any numbers in there. Like this side A and this side B, it's kind of hard to tell which one's which, if one's bigger than the other. Would you agree? All right, because I didn't draw it exactly perfectly accurate, okay? So sometimes they don't draw the picture accurately. Some of you guys took the PSAT. Did you see any geometry stuff on the PSAT yesterday for those who took the test? Did you see anything where it said it's not drawn to scale or anything like that? I don't know if you had a problem like that on there or not. They used to have stuff like that a lot on there. Okay, you did see it? Okay. All right. So what we're going to do is we want to list the sides in order from the biggest to the smallest. Which one is the biggest side on this triangle right here?
B.
Side B. Which one is the smallest one?
C.
Why C? How do you know? Because it's opposite the 20. That's right. Everybody see that? Why is B the biggest side? It's opposite the biggest angle. Why is C the smallest side? Because it's opposite the what? The smallest angle. So which one's in the middle? The A. All right, now here's how we write it. Let's watch. B is greater than A. How do we write greater? Like that. Agree? So B is bigger than A, and A is bigger than C. This is the way that they want you to write in order. That would be the largest, that would be the middle one, that would be the smallest one. Okay, notice what direction your inequalities are going to go. This thing right there, that little greater than, that's called an inequality because it's not equal. Okay? Everybody with me on that? Let's take a wild guess on the next one. It's not really a wild guess, it's an educated guess because we kind of saw what happened here. Now watch, they're going to say that the length of that side is 13, the length of this is 14, and the length of this is 12. Now what do you think they're going to do? They give you the sides of the triangle. What do you think they're going to ask you to find? The length, the measure of the angles. That's right. Okay. Let's take the biggest angle, then the medium angle, and then the smallest angle. So which one do you think is the largest angle in this situation right here? It's M. Why? Because it's opposite what? The biggest side. See how that's the biggest side? Then angle M is the biggest angle. What do you think? Let's go to the smallest. What do you think the smallest angle is? It's LM or N. You know it's not M because we already did that. It's L. How do you know it's L? Because it's opposite the smallest side. So angle L, that angle symbol, my L kind of look the same. What's the middle angle then? It's angle N. That's right. Because 13 is in between 12 and 14. All right, so N is the middle one. So that's the middle one. And then what do we do with our inequalities? Angle M is what? Greater. And then angle N is greater than that one. See, that's the biggest one. That's the middle one. That's the smallest one. That is what they're asking you to do. Remember what the question is. I didn't write it down. I told it to you, but remember what the question was. List in order, okay, the measure of the angles from largest to smallest. What if they said from smallest to largest? What would I do here? Then C, then A, then B. But what would I do? Would I go C is greater than? No, I would say C is less than and A is less than. It basically means the same thing, doesn't it?
Yep.
All right. If I read it from right to left, watch. If I read from right to left, B is what? Greater than A, which is what? Greater than C. Isn't that what that's saying? We just reversed it. What could I do here? What if I asked you to put it in order from the smallest one to the largest one? Which one's the smallest one? Angle L. Which one's the medium one? Angle N. Which one's the biggest one? Angle M. But if I go from smallest to biggest, how am I going to do my inequality? That's less than, that's less than. So this would be from the smallest to the biggest. This would be from the biggest to the smallest. Same thing here. Okay, enough of that. Let's do another thing.
Are you guys laughing during this lecture?
Let's do this. Let's draw a right triangle. So what do I know about a right triangle? What's special about a right triangle? It has a what kind of an angle? 90-degree angle. It's got a right angle, doesn't it? Why are we packing up? I shouldn't hear zipping up. We're not done. We have several minutes left. Bell's not even going to ring any second. You got several minutes. Just by looking at that right triangle, tell me, what is the largest side of that right triangle? Opposite the what? The right angle. Amir, what'd you say? Exactly right. It's called the hypotenuse. The hypotenuse is always the largest side of a right triangle. Why? Because 90 degrees in a right triangle is always going to be the biggest angle. Did you hear me?
Yes.
Some of you guys are starting to fool around a little bit, so let's pay attention. Stop. Don't need it. So if this is 90 degrees, this angle is opposite the 90 degrees. We give that a special name. We call it the hypotenuse. Okay? The hypotenuse is always the largest side in a right triangle. And that's one of my theorems. I'm not going to write the whole thing down. We just discussed it. That's a theorem. All right? It's something in the geometry book that they tell you the hypotenuse is always the largest side of a right triangle. Okay? Let's do another thing that we've actually kind of talked about a little bit when we did that circumcenter and all that kind of stuff. We didn't actually do this with circumcenter, but let's say I put a point right here. Now, I'm not going to have you come up here and do this, but what is the shortest length from that point to this line right here? So if I wanted to get from that point to that line, what's the shortest distance? Straight? That's straight.
No, I meant like there.
Perpendicular. That's what I want to hear, okay? It's perpendicular, okay? Don't just say straight, because look, that's a straight line. That's a straight line, isn't it? Is that the shortest distance from here to here? No. Okay, it's perpendicular. Don't even say straight up and down. Say what? Perpendicular. So that's another theorem, okay? This theorem says that the shortest, you've probably heard this before, haven't you? The shortest distance between 2 points is a what? You've never heard that before? Is a straight line? You never heard that? Yeah, it's a common thing. All right, I don't know. Maybe you just don't remember it. I don't know. But what's the shortest distance from a point to a line? It's perpendicular. It's the perpendicular distance, okay? That's super important. That's what the shortest distance is. All right? Let's see. I only got a minute left. I don't think I have enough time to do this. But there's one that is called the longer side theorem. By the time I even draw the picture, the bell will ring, so I'm not going to do it, okay? But here's what I want you to do. Okay, go look on one of the other videos from section 5.3. You can look at the honors. Go to the honors class from this year, okay, and section 5.3, and you can see the longer side theorem. Maybe we'll talk about it briefly tomorrow. But here, you've got some homework. So it's section 5.3. This page is 224, 225. And you're doing 1 to 18. If you were one of the 4 that were here yesterday, you might already have that done because it should have been assigned to you yesterday. But if you weren't here, I did say to assign it though on the paper. But anyway, there's your homework. That is due tomorrow. That's due tomorrow. 1 to 18, have it done.